Welcome student to the first part of solving optimization problem using Lagrange multiplier. So in the first example, we will use Lagrange multiplier to find the maximum value and the minimum value for the function f of xy equal x squared minus y squared, but it will be subject to the constraint that x squared plus y squared equal to 1. So once we have a constraint, Lagrange multiplier will be useful. Of course, if we don't have a constraint, we need to use the critical point idea, where we find the first derivative and we check if it's maximum and minimum using the second derivative test. But now, since we have only a constraint, we are only looking at values of x, y that satisfy this equation. And that's where Lagrange multiplier comes handy here. And if you remember, in Lagrange multiplier, what we need to do is we need to solve a system of equations. The first equation in the system, we need to find the derivative at fx, and we make it equal to lambda, the derivative of g of x. And then we need to find the same thing for the y, lambda g of y. And finally, we need to write the equation, the constraint itself, as a further equation, which will give me 3 equations, 1, 2, 3, and I have 3 unknowns, which are x, y, and lambda. So let's see what we get from each equation, and then we will see how we will solve each one. Fx will be just 2x equal lambda. G of x, it will be again 2x. Equation number 2, it will be 2y or negative 2y equal lambda 2y. And finally, equation number 3, we write it as is, x squared plus y squared equal to 1. That's the third equation. Now, we need to start dealing with the equation one by one. So let me go in equation number 1. So I will just write using equation, or starting with equation number 1. Now what's equation number 1? We have 2x equal 2 lambda x. Of course, easy peasy, you can think that you can divide by x, but again, do not divide by x. The reason why? We don't know the value of x. Maybe x will be 0, and what you will do is you will divide by 0, and that will exclude an option for the solution. So if you don't have any information that x equal to 0, do not divide by x. Okay, what shall we do? Now, of course, 2 and 2, you can cancel it. So you will end up with x equal lambda x. Now what you need to do here is take this one, this side, to the other side with a negative sign. That's a better idea. So you will get x negative lambda x equal to 0. That means x and then 1 minus lambda equal to 0. Of course, if we have this situation where we have 2 numbers, we multiply them, we get 0. That means either the first one is 0 or the second one is 0. That's the 2 options that we have here. So we have case 1, x equal to 0. Once I finish from case number 1, I will go back and find what will happen in case number 2, and I will collect all the answer. So case number 1, x equal to 0. Let's try to find what we can find. Now, we use equation number 1, so I don't need to use it again. Now, which equation has x and one other variable? It's equation number 3. So let's chase equation number 3. So substitute x equal to 0 into equation number 3. Now, what was equation number 3? It was x squared plus y squared equal to 1. Now, if we put x equal to 0, this means y squared equal to 1. So either we have y equal 1 or y equal -1. So we have two choices here. And what we are going to do, we substitute in equation number 2. Substitute into equation number 2. Now, what is equation number 2 that we need to substitute in? Let me just... Equation number 2. What are the two equations that we have here? Equation number 2, it was -2y equal lambda 2y. Now we substitute 1. So we get -2 equal, now if we substitute 1, we get 2 lambda, and so lambda equal -1. So this case will give me this one. Now let's see this case where it will give me if I substitute in equation number 2, again lambda 2y. If we do the calculation, if we do -2 with -1 with -2, this is 2 equal -2 lambda, again lambda equal -1, which is the same. So that's all what we get. We get x equal to 0, lambda equal -1, and we have two options for the y, either 1 or -1. That's all the information we extracted from case number 1 where x equal to 0. What we will do next is we will go to case number 2, which is this tiny little case here, 1 minus lambda equal to 0, and we will find the value for the lambda. Case 2, lambda equal to 1. Remember why lambda equal to 1? Because 1 minus lambda is equal to 0. Now substitute lambda equal to 1 into equation number 2, as we just did. Remember, equation number 2 was -2y equal 2 lambda y. That means I will get 2 -y to the left side. If we substitute 1, I get 2y. So if I take, of course, do not divide by y. We don't know if y equal to 0. Take this to the other side. You will get -4 equal to 0. That means y itself equal to 0. So far, everything looks good. The last step here is we substitute in equation number 1. So equation number 3, substitute y equal to 0 into equation number 3. Now what's equation number 3? It was x squared plus y squared equal to 1. If we substitute y equal to 0, I will get x squared equal to 1. That will leave me with two options for the x, either 1 or -1. And now we find all the values from all the branches, from all the cases. So what we need to do next is we need just to make our final table where we write all those answers. You write all the lambdas, you write all the possible values for x, y, and what we need to do next also is to evaluate the function itself, which was x squared minus y squared, in those values. Now, let me go back. We can see that we have two options for the lambda that we found in the previous slide. Either lambda equal to 1, which give me y equal to 0, and x equal to 1 and 0, or -1 and 0. And we have negative lambda So this one here, like I need to do this. The second one, lambda minus 1, x is 0, y 1, or 0, negative 1. This is the table that we need to fill. Okay, if we fill this table, this will be 1, 1, and this will be negative 1, negative 1. Now, we write the final answer, which is, looking at this table, what is the maximum value and what is the minimum value. The maximum value is a clear 1, the minimum value is a clear negative 1. And that's the final answer that we have here for this optimization problem. Thank you.